Hello everyone, my name is Oorja and today we'll be learning about nomenclature of organic compounds. At DhiNexus, we try to make learning simple, clear and engaging. So please stay tuned till the end of the session to learn more about this. So first we'll begin with uh, what are organic compounds? Organic compounds can be classified on the basis of two things. At first you have acyclic compounds or open chain compounds. These are also called as aliphatic compounds. These are primarily the straight chains that we see. For example, you can have CH3, CH2, CHO. This is, if some of you may already know about this is known as propanol. These are nothing but straight chain organic compounds. Next, we have cyclic or closed or ring compounds. These are also divided into acyclic or aromatic. Now, what are acyclic compounds? Acyclic compounds are those that have alicyclic. Alicyclic compounds are those which are divided into two parts. These can be homocyclic or heterocyclic. Homocyclic compounds would primarily mean those that have only carbon atoms. Only the same type of atoms are there, and those are nothing but carbon atoms. These are some compounds of alicyclic homocyclic. Cyclohexene, and you also have, this should be there's an error in the book, should be cyclohexane, and this should be cyclohexene as we have a double bond. And the other is heterocyclic. Now, what is the difference between homocyclic and heterocyclic? Homocyclic compounds, like I already said, are those which have all the carbon atoms as same. In heterocyclic, the carbon atom, one of them is going to be different. So an example of this is tetrahydrofuran. This is in short known as THF. Next, like we saw earlier, we have alicyclic. What do we have next? In the ring compounds, we have aromatic compounds. Now, aromatic compounds can also be divided into two types. We have benzoid and we have non-benzoid. Aromatic compounds, let's have a look. So, benzoid compounds are those which have benzene. This is highly important and comprises a lot of reactions are based off this. C6H6 is the formula of benzene. Next is aniline, naphthalene. These are benzoid aromatic. Non-benzoid compounds are propon is one of the examples. We have alicyclic, heterocyclic compounds as well. Oxirane, pyrrolidine, and some more heterocyclic aromatic compounds include furan, thiophene, and pyrrole. If you want, you can please pause the video and note down all of these examples one by one. Now, before moving forward, I would like to highlight that this video will be helpful for anyone who is preparing for CBSE board exam, ICSE exams. You can also be somebody who's preparing for NEET exam, IIT-JEE, or even if you're from another board, IB board, this would be helpful for you. Because organic compounds, the basic starts from the nomenclature. If you're not able to identify how to name a particular compound, you cannot understand more things. You cannot learn to, name the reactions, or you cannot learn to predict what the product is going to be. So this is the, you can say, the baby step of moving forward. Next, we have nomenclature. So IUPAC, basically nomenclature of organic compounds is of two types. First is IUPAC, and next is common names, also known as trivial names. What is IUPAC body? If anybody is aware of it, this is International Union of Pure Applied Chemistry. So this body it has given out some rules as to on what basis the nomenclature of compounds is going. Now, common names, however, don't have any specific names. These are, were derived. Like, for example, if I'm talking about citric acid. Citric acid is found in citrus fruits. So the origin, was used to name some of the compounds. For example, we also have formic acid. Formic acid, if you know, is HCOOH. Now, this is found in forma. What is forma? This is Latin for red ant. Okay. So these are some common names that one may have to learn and would be beneficial if you learn it. Coming to IUPAC names of unbranched saturated chain. What is saturated, unsaturated? Let's take a moment to discuss those two. Organic compounds can be divided into two types. Unsaturated and saturated. Now, what is unsaturated? Unsaturated. Let's see. Saturated compounds are those which have only carbon-carbon single bond. So my alkanes are saturated compounds. Their formula is CnH2n plus 2. Unsaturated is divided into two types. You have alkenes and alkynes. Alkenes is, the formula is CnH2n. Alkynes would be CnH2n minus 2. This, we're talking about alkanes. As you can see, at the end, we have A and E. CHO, C2H6, that is for ethane. So remember the word root. If we have one carbon, it would be meth, methane, eth for 2, prop is used for 3, but is used for 4, pen is for C5H12. H12 here is because it is pentane, but if I was suppose going to write about pentene, pentene would have the structure as this. Remember, whenever I've not drawn other bonds, they will always be satisfied with hydrogen. Everywhere else I have hydrogen. 1, 2, 3. So it needs only one hydrogen and this needs 2 hydrogen. So what would be the formula of this? C5H10. If you count the number of hydrogen atoms, they would come out with C5H10. Moving on, hex is for 6 carbon, hept for 7, oct, 8, and so on. Coming to the next part. Before that, first we'll see some rules of unbranched nomenclature. Rather, branched nomenclature chain. So the first step that we must know is that we prefer the longest carbon chain. Longest carbon chain is used to decide the parent chain. For example, I have this. And so I am not, in this case, I am not going to take this as my parent chain. Why? Because it has 4 carbons. If I were to name it, it would be but. The parent would come out to be but. But I can see that this one has 5 carbons. So it should be pentane. That should be the parent chain. So the first rule is that we select the longest carbon chain. Next is the numbering in case of we have a branch chain is done in such a way that the branch chain gets the lowest number. I have this. There are 2 branches available and I have, draw it again. So I should start my numbering from here and not from here. Otherwise, the branching would get 4 number if I do it from here, which is not feasible. And this one is preferred. So the naming of this should be, I will also tell the name. This should be 2,2 dimethyl pentane. Why did I write it like dimethyl? What is the why? When do we write the comma dash? We're going to just see that in the next part. Next is just like I wrote it in the previous question. Whenever I have to, so if I just write the name of it first, it should be 2-methyl butane. So the number and word, these are separated by a dash. And suppose I had one more methyl group here. It would be CH3 here like this. Then it would have become 2,2 dimethyl. This would have become 2,2 dimethyl butane. Moving on to the next one. And why am I using the word di? Di is used because there are 2 methyl groups. If I had one more CH3 here, this would have become trimethyl. So for 2, it is used di. For 3, we use tri. For 4, we use tetra. And so on. Next is, if there are 2 or more identical substituents present, the numbers are separated by commas like we already discussed, and we use, suppose I have C2H5. What is C2H5? Let's just take a moment to discuss these two. This is called methyl. This is called methyl. C2H5 is called ethyl. How am I getting methyl ethyl? From alkane itself. CH4. If I reduce one hydrogen, what I get is CH3. This is a methyl. So what I see is alkane, if you remove one hydrogen, get alkyl. This is the basic idea of writing the alkyl groups. So C2H5, remember, is going to have ethyl. And the general formula of alkyl would be one hydrogen less. So in case of alkene, the formula is suppose CnH2n plus 2. So here it would become CnH2n plus 1. One of the hydrogen will be reduced. So hence we get this. Now, I have this compound, I have this compound. CH3 and C2H5. Where should the numbering begin from? 1, 2, 3 or 1, 2, 3, 4. If I name it from here, the numbering would be 3-methyl. Sorry. Let me draw it again neatly. I have CH3, CH2, CH2, and CH3. C2H5 here, and I have, this is CH3. So I try to number it like this. So what I'm getting is 2-ethyl, 3-methyl butane. And this is the correct number because alphabetically E comes first before M. This is how it should be. Next is lower number is given to the one that is alphabetically. So there are some rules that will be overlapped. Okay. Right. Carbon atom of the branch that attaches to the root alkene is numbered like this. Okay. What should be the meaning of this one? It would be we have 1, 2, 3, 4. So 2-ethyl butane. Moving on, there are certain cases of cyclic compounds as well that we should be aware. The naming is pretty much the same. If I have this, what is the way to name it? This is, as we can see, let's take it here. 1, 2, 3, 4, and 5. Since there is no double bond, we can say is a pentene. If it is a closed compound, it is called cyclopentane. If I have branching, then what happens? In such a case, this is 1, 2, 3. Now, this, if I have only single dash like this, it indicates methane or methyl actually. So this is methyl, this is ethyl, right? How will the numbering be? Not ethyl, so 1, 2, 3. This is propyl. What would the naming be like? 1 methyl, 3 propyl, cyclo. How many carbons are there? 1, 2, 3, 4, 5, 6. So it should be cyclohexane. However, be careful if at one place there is more branching. I have more branching here like this. So what should the numbering be? This is, although this is ethyl and these are two methyl. The numbering won't begin from here, even though this is coming alphabetically first before M. Numbering will be from here as this has more branching to it. So should be 3-ethyl 1,1 dimethyl cyclohexane. As we're clear with the rules, the next point of discussion is what are functional groups. So functional groups are those compounds which can change the property of a particular carbon chain that. Right? Now, functional groups can be many. You can have alkanes, alkenes, alkynes. We already know that the way to write it is like this. We have a functional. There's no prefix in this case, there's a suffix. Now, one thing that I should have mentioned before is that in general, IUPAC naming is done in such a way that you have prefix, then you have a word root. Word root would be something like, example would be, suppose I have CH4, so it would be meth. Right? This is word root plus suffix. This is the general way of writing the IUPAC name. So, functional group, in case I have an alkane, I know I write AN. Alkenes, EN. Ines would be 1. Arenes are benzene, that is the one example of it. Halides, you have all the group 17 elements. What are group 17 elements? These are called halogens. Hence, the prefix is used as halo. Now, why are we using prefix in some cases and not in other cases? We'll just discuss about that in a while. Alcohols can be used both as prefixes and suffixes. These are some lists. You can pause it and note them down because this is going to be highly important. Now, coming back to the discussion as to why only some compounds are prefixes and not the other. See, if I have, suppose, two functional groups present. I have CHO and I have Cl. In such a case, if I have two functional groups, one of them is going to act as a substituent, and that is that functional group which is not as important. Or like, see, one of them is will be given a priority. So in this case, it will be CHO. CHO is an aldehyde. It is given the priority. And the numbering will be done like this. 1, 2, 3, 4. Please remember that aldehyde is an terminating group, which means that it will always be at the terminal end. So I cannot say that two, would be written here. So this should be like this. What would be the name of this compound? This would be 3-chloro 2-methyl butanol. Why did I write butanol? Because if you look at the aldehydes, which is given in here, when I have that as the main suffix is used, then it is al added at the end. If I had something like this, CH3, C double bond O, CH3. Now this is nothing but my classic example of a ketone. Ketones are written, their general formula is ROR. In case of, this is for ketones, sorry. And for aldehyde, it is RCHO. Alcohols are ROH. Aldehydes are RX. This is RCOR, like I already said. Nitriles are RCN. Ethers are ROR. Then this can be RCOH, RCO minus, RCOR. Acyl is this RNH2, NH, and N, and so on. Moving on, we have one more thing that we are left to discuss with is the priority table. Now, on what basis is the priority table decided? Let's take a quick look. Basically, if I have functional groups, like I already said, if I have many functional groups present together, then how will I name it? Number it or decide the priority. So a quick learning for that is important. Suppose I have, so please note down, this is the priority table. At first I write, and it is in the decreasing manner. So at first you will have COOH, then we have SO3H, then COOR, then we'll have COCl, CONH2, CN, then we have HCO, OH, and there is NH2. Then we have double bonds, and then we have triple bonds at the very end. Okay. So this we can say is an acid. This is sulfonyl group. This is an ester, acyl group. This is amide. This is nitrile. This is alcohol. Right? And we can also have a double bond here. Then we have a triple bond. After triple bond, we get X, which is fluorine, chlorine, bromine, and iodine. And lastly, we have R, which is an alkyl. So in such a manner, we should decide where should the numbering start from. Carboxylic acids top the list. So that is all for nomenclature in today's class. And we'll study more about nomenclature in the next classes, where we'll see more the examples and questions and how to solve. If you like this video, then I would suggest that you share it with your friends, because they would also get some help out of it. At DhiNexus, we try to make learning clear and concise. So if you really like it, then please like, subscribe, and share it. Thank you.